All right, so this is the last form of transformations that we're going to be talking about. It's dilations. So dilation, if you think about it, if you guys go to like the eye doctor and they put the drops in your eyes to dilate your eyes, it kind of like makes your pupils expand, right? So that they are able to see if there's anything wrong with inside your eye. So dilation is an expanding or an enlargement, but it also could be a reduction, which means to shrink something. So basically the size of a shape or the size of the figure is going to be enlarged or reduced by what's called a scale factor. Okay, so now dilation, something that's really important for you to know. Dilations, so we talked about how like a translation, it preserves, means it keeps, it has no change on the size of the shape or on the orientation, the direction that the shape is facing, right? So if this is my object and I'm translating it up, it stays facing the exact same position. If I'm moving it to the left a little bit, it stays facing the exact same position. Whereas a rotation is going to change the direction that it's pointing. A reflection, if I do a reflection and do it this way, it's going to change, you know, what originally was showing. It's going to be in a reverse position. So those things change orientation, but they all three preserve the size, right? Not a single one of those ever change the size. The dilations, though, are the only transformation that has an effect on size. It is the only transformation that's going to either shrink it down, make it smaller, or enlarge it, make it bigger. Okay, so it's the only one that has a change of size on the original figure. So we'll get that put down. Now, dilations don't change the orientation though. Okay, when a dilation happens, the shape is still facing the exact same direction. It only has an effect on size itself. Now, if you do a combination of things, like a combination of reflections and dilations, then that would have an effect on orientation and size. But dilation by itself only affects the size. And how it affects it is based off of what's called a scale factor. So the scale factor, we call it a K value. So you know when you have your coordinate system, your coordinate grid is going to be an X and a Y. Well, you've got a K that is a value that's going to, you know, alter your pre-image. And the way that it does that is because you are multiplying. You're going to multiply your pre-image by this scale factor in order to get the dilated image, whether it gets bigger or smaller. Okay, and like I said before, you've got two different ways to dilate your figure. You can dilate it by making it an enlargement. And it's important to keep it proportional. So how many of you have ever, when doing like a class project, and you take an image from Google and you put it into your Word document and you're like, oh, I want it to be a bigger document, and you start moving it, but you move it by like the sides or by the top and the bottom, and it kind of changes the look of the picture. You know, like if you take a picture of a person and you're like, oh, I just want to spread it off across the page, and it makes their face look fatter. Or, ooh, I want it to make it as tall as I can, and then it makes them look like they've got, like, you know, the elephant trunk for a face because it's really, really long. in order to be able to do a true dilation, instead of dragging it by the sides or by the tops and bottoms, you have to drag it by the what? Anybody know? The not the middle, but the corners. The corner keeps it proportional. So it will, if you take the corner of your picture and you drag it down, it's going to naturally drag it to the side as well in order to keep it proportional, so that way it stays a similar but dilated figure. So an enlarged figure, or if you try to make it smaller, it makes it a reduced figure, okay? And it does that because the computers have it locked in as a scale factor when you do the corner drag. So an enlargement, when you take an enlargement, your scale factor, your K value, is going to be greater than 1. It's not equal to 1, because if we multiply by 1, it doesn't change anything. Okay, so it would be a value that is greater than 1. If you do a reduction, okay, so again, a reduction is going to make it smaller. So your scale factor in this case is going to be smaller than 1, but it has to be greater than 0. So your K is going to be greater than 0, but less than 1. It's greater than 0, but less than 1. We don't have negative values for our scale factor, only positive values. So in order for it to be smaller, a lot of people think, well, if I'm going to make it smaller, then I have to divide. Well, not necessarily. Division isn't always the only way to be able to get a smaller number. When you multiply by a fractional value between 0 and 1, that reduces the size of the value, or reduces the number itself. Okay? So again, you would be taking your original. We're going to take our original. Our original coordinate is just x, y. And then when we do the dilation, when it becomes dilated, you're going to multiply the x by k, and then you're going to multiply your y by k. And there becomes your dilated point. Okay, so let's try one on our own. Let's say that we have a triangle, and the triangle has points A, B, and C, and point A is at 4, 6. Point B is at 10, 8. And point C is at 5, 14. So those are the coordinates. And then my scale factor, is 1/2. The scale factor is 1/2. Okay, so in order for me to do each of these points, I'm going to go ahead and rewrite them again down here. So A was 4, 6. B was 10, 8. C was 5, 14. In order for me to go ahead and get a new value, a primed value, by a scale factor of 1/2, all I'm going to do is just multiply each of my coordinates by 1/2. So it's a little bit different than translation. Translation is very specific to the x and specific to the y. You might change your x but not change your y, or you might change your y and not change your x, or you might change both, and both in a different manner. With a scale factor, the scale factor happens to both of your coordinates equally. Okay, so you're multiplying both parts of your coordinate by the scale factor. So if we do 4 times 1/2, then A prime is going to be at 2, and then 6 times 1/2 is 3. So there's A prime. A prime is at the values 2, 3. Go ahead and do B prime and C prime on your own. All right, so B prime. Trey, what did you get for B prime? 5, 4. Very good. When we multiply 10 by 1/2, we get 5. When we multiply 8 by 1/2, we get 4. So B prime is at 5, 4. C prime. Jerry, what did you get for C prime?
2.5 and 7.
2.5 and 7. Very good. And it's okay to have a decimal value, guys, for your coordinate. It's perfectly fine to have a decimal value for your coordinate. 5 times 1/2 is going to give you 2.5, and then 14 times 1/2 is going to give you 7. Let's go ahead and try one more. I'm just going to give you 2 points. So let's say that A is located at -4, 3, and B is located at 1.6 and -5, and your scale factor is a value of 9. The scale factor is a value of 9. Go ahead and tell me what the primed values are going to be. Okay, A prime, Brian, what is that going to be? Very good. So A prime is at -36, +27. If you multiply -4 times 9, that's going to give you -36. And then 3 times 9 is going to give you 27. Okay, what about B prime? B prime, what is that going to be located at, Hannah? Good, 14.4 and -45. 1.6 times 9 is going to give you 14.4, and then -5 times 9 is going to give you -45. And that's the basic idea of our dilations. Very, very simple, easy process. So what I want you to do now is to get your dilation card out, your dilations card for your flashcards. And then on the back of the dilations card, you're going to put down the rule. And the rule is K times X, K times Y.